The graph shows part of the curve C with the equation y equals minus x cubed plus 2x squared plus 8x. The curve C crosses the x-axis at the origin and points A, B. The origin, A, B. Part A, using an appropriate algebraic method, find the coordinates of A and B. Well, I know at these points here, the y coordinate is going to equal 0. So if I take my equation here, make it equal to 0, my appropriate algebraic method is going to be to factorise I'm going to factorise a minus x outside here. So that's going to make that an x squared, that a minus 2x, and we'll have a minus 8 there. So this times this is this. This times this is this. And this times this is that. I can now factorise that quadratic easily. That's why I wanted to take the minus outside. So I'm going to have a plus 2 and a minus 4. So that gives me three solutions. Either the x is 0, the x is minus 2, or the x is 4. So the coordinate of A is minus 2, 0. The coordinate of B is 4, 0. Part B. The finite region shown shaded by the curve C in the x-axis is bounded by the curve C in the x-axis. Use calculus to find the total area of that shaded region. So I want to work out the red area. Now the important thing to note here is that the area here, I'll call it R1, is below the x-axis, so that's negative. Whereas the area here, R2, is above the x-axis, so that's going to be positive. So I have to work out these two areas separately. That's really important. Otherwise, they're going to cancel each other out. So let's do R1 first of all. That's going to be the integral from the lower limit is minus 2, the upper limit is 0, and the integral that we're doing is minus x cubed plus 2x squared plus 8x with respect to x. Integrating each of these, the x cubed will integrate to be x to the power 4 divided by 4. The 2x squared is going to integrate to be 2/3 x cubed. And the 8x is going to integrate to be 4x squared. Substituting the limits in, so substitute the 0 in first. We're substituting the 0 into all of those terms, we'll just give 0. Now substituting the minus 2 into all of those terms. So just on my calculator now then. So 0 take away 20 over 3 is minus 20 over 3. That minus is, remember, is just telling me the fact that the R1 is below the x-axis. So I'm, in terms of the numerical value of the area, I'm not bothered about the minus there. So I'm just going to say that R1 is 20 over 3. the area has to be positive. Let's now do R2. Well, R2 is going to be the integral. The lower limit now is 0, the upper limit is 4. Same equation, it's still bounded by the same curve. So when we integrate, we'll get the same answer. The minus 1/4 x to the power 4, the 2/3 x cubed, the 4x squared. The upper limit is 4, the lower limit is 0. Substituting the 4 in, so we've got minus 1/4, 4 to the power 4, plus 2/3, 4 to the power 3, plus 4 lots of the 4 squared. If I substitute 0 into the lower limit, 0 into all of those terms, I'll get 0. So again, on my calculator, that gives me 128 over 3. So that is the area of R2. Therefore, the total area is going to be R1 plus R2. So adding those together, I get 148 over 3. And that is my answer.